Hi, it's Rob. Welcome to another Cumulus Cycles AWS Hands-On tutorial. In this video, we'll build a VPC and related infrastructure for a 3-tier network using CloudFormation. If you're new to working with AWS or creating VPCs, I recommend you watch my video on creating a custom VPC with public and private subnets via the console. It's always good to see what you're building before jumping in and building with infrastructure as code. And the AWS console is a perfect place to do that. I'll put a link to the video in the description section below. Before we dive into building YAML templates for the infrastructure, I want to draw your attention to the AWS Cloudformation Documentation, and specifically the Working with AWS Cloudformation Templates section. I recommend you bookmark this page now if you're going to be spending much time with CloudFormation. This site is your one-stop shop for documentation on building CloudFormation templates. To get started, we'll build the template for the VPC, which will include an internet gateway and public and private subnets into availability zones. We'll also add route tables and associations, as well as security groups. Here I've created a template.yaml file for the VPC. I've added the AWS template format version and a description, as well as a resources section. In the resources, I've started by creating a resource for the VPC, the internet gateway, and the internet gateway attachment. The VPC will be an AWS EC2 VPC type with a CIDR range of 10.0.0.0/16. Its instance tenancy will be default, and I've added a tag. The internet gateway will be an AWS EC2 internet gateway type, and I've also given it a tag. Finally, the internet gateway attachment will be an AWS EC2 VPC gateway attachment type, and its properties for the internet gateway ID will be a reference to the internet gateway created above, and the VPC ID will be a reference to the VPC created above. For the public subnets, I've added resources for the public subnet 1 and public subnet 2. Both subnets will be AWS EC2 subnet types, and for the availability zone, I'll use the select intrinsic function to get the element at the 0th and 1st position in the list of AZs. Public subnet 1 will have a CIDR of 10.0.0.0/24, and public subnet 2 will have a CIDR of 10.0.1.0/24. Both subnets' VPC ID values will reference the VPC created above. For the route tables, the routes, and the route table associations, I've also added resources. The public route table will be an AWS EC2 route table type, and its VPC ID property will be a reference to the VPC. The public route will be an AWS EC2 route. Its destination CIDR block will be wide open. Its gateway ID property will be a reference to the internet gateway, and its route table ID will be a reference to the public route table. I've added resources for the public subnet 1 and public subnet 2 route table associations. These are both AWS EC2 subnet route table association types, and both route table associations will have a route table ID property pointing to the public route table. The public subnet 1 route table association will have a subnet ID, which is a reference to the public subnet 1, and the public subnet 2 route table association's subnet ID will be a reference to public subnet 2. I've added resources for the security groups, one for the application load balancer on port 80, one for an SSH security group on port 22, a security group for the application servers on ports 80 and 443, and a security group for the database layer, which will be RDS on port 3306. All of the security groups are of type AWS EC2 security group. The ALB security group has a security group ingress property, which is a list of IP protocol TCP on ports 80 and 443. The VPC ID is a reference to the VPC. The SSH security group has a security group ingress for TCP on port 22. And the web server security group provides ingress on ports 80, 443, and 22, with security group IDs for ports 80 and 443 being references to the ALB security group. And port 22 has a security group ID as a reference to the SSH security group. And finally, the database security group has security group ingress on ports 3306 for the MySQL RDS database, with a security group ID as a reference to the web server security group. In the output section in the template, I've added outputs for the VPC, the subnets, and the security groups. Now, with the template created, I could jump over to a terminal and execute AWS Cloudformation Validate template, passing it the template body, which is the YAML file I just created. And it looks like our template has passed validation. To give you an example of what it looks like when a template fails validation, I'll jump back into VS Code and just comment out the mandatory resources section and then validate again. In here we see there was an error validating the template. So I'll just jump back and fix that. Save it, validate again just to make sure. Looks good. And then execute AWS Cloudformation Create Stack. I'll give the stack a name of ccVPC, and again reference the YAML file for the template. We've gotten back a stack ID, and if we jump over to the CloudFormation console and refresh, we see our stack's creation is in progress. And after pausing the video and waiting a few minutes, we see that our stack creation is complete. If we go into the Resources tab, we'll see all the resources that were created. In the Output section, we'll show the details for the resources we added to the Output section in our template. With the VPC in place, we can now move on and create the template to build the NAT gateways, route tables, routes, and associations for the subnets. In the NAT Gateway template YAML file, I've added resources for NAT Gateway 1 Elastic IP and NAT Gateway 2. These are both AWS EC2 EIP types. Their domain properties are VPC, and I've added tags for both. The NAT Gateway 1 and NAT Gateway 2 resources are AWS EC2 NAT Gateway types. The NAT Gateway 1 has an allocation ID property, which we'll get as an attribute from the NAT Gateway 1 EIP's allocation ID. The subnet ID will be imported from the VPC's public subnet 1 we created in the VPC template. The NAT Gateway 2 has a similar structure, but with its allocation ID coming from the NAT Gateway 2 EIP. I've added a resource for the private route table 1 and private route 1. The route table's type is an AWS EC2 route table. Its VPC ID property will be imported from the VPC. And private route 1 will be an AWS EC2 route. Its destination CIDR will be wide open. Its NAT Gateway ID will be a reference to the NAT Gateway 1, and the route table ID will be a reference to the private route table 1. I've added route table associations for the private app subnet 1 and database subnet 1. They're both AWS EC2 subnet route table associations. The route table property for the private app subnet 1 route table association is a reference to the private route table 1. And the subnet ID will be imported from the VPC's private app subnet 1. And the private database subnet 1 route table association's subnet ID will be imported from the VPC's private DB subnet 1. And I've created similar resources for the private route table 2, private route 2, and private subnet associations for the app subnet 2 and DB subnet 2. So I'll save the template, jump over to the terminal, and validate the template. Oh, and it looks like I didn't validate it. I just went ahead and created the stack. And here we have our stack ID. And if we jump back over to the CloudFormation console and refresh, we'll see that the NAT gateway stack is create in progress. And after pausing the video for some time again, we now see that our NAT gateway stack is created. And here are our resources. Now we can turn our attention for creating the resources for the RDS database. In the RDS template YAML file, I've added a resource for the database subnet group. This will be an AWS RDS DB subnet group type. I've given it a DB subnet group description and a list of subnet IDs, which will be imported from the VPC, pointing to the private DB subnet 1 and private DB subnet 2. The database instance will be an AWS RDS DB instance type, and I've given values for the properties. The DB instance's availability zone will be the first element in the available AZs. Its DB instance class will be DB-T2 micro, and the instance identifier will be MySQLDB. For the DB name, the master username, and master user password, I'm including references to parameters in SSM parameter store instead of hard coding them into the template. So let's jump over to the AWS console and add these parameters to parameter store. So here I'll click create parameter to get started. And the first parameter I want to add is for the DB name. So I'll enter the value for the name and then its value, which will be ccDB, and create the parameter. Then I'll create parameters for the DB username and DB user password. Then I'll create the stack. Now our RDS stack is complete. If we jump over into resources, we see the subnet group in the database instance, and in the RDS management console, we see the MySQL database. So we're making really good progress on our infrastructure. We have our VPC, the NAT gateway, and the RDS databases. So let's move on and create the template for the EC2 instances. In the EC2 template YAML file, I've added a mapping section for the AWS instance type architecture. It has entries for T1 and T2 micro, as well as T2 small and T2 mediums. In the resources section, I've added resources for Web Server 1 and Web Server 2. They'll both be AWS EC2 instance types. And in the first instance, I've specified the instance type in the template. For the image ID for instance 1, I'll create an EC2 AMI ID parameter in parameter store. And the value for that can be obtained by going to the EC2 dashboard, launching an instance, and selecting Amazon Linux and the Amazon Linux 2 AMI, then copying the AMI ID. So with this information, I'll jump into parameter store and create the parameter. Web Server 1 subnet ID will be imported from the VPC and point to the private app subnet 1. The security group will also be imported from the VPC and point to the web server security group. We'll need a key name for the instance, which I'll store as a parameter named key pair. So I'll jump over to the EC2 console again and create a key pair. Then back to parameter store and create the parameter. I'll give this instance a tag with a name of CC Web Server 1. And the user data script will set the bash interpreter elevate privileges, do a yum update, and then install HTTPD. I'll create an index.html file in the HTTPD's var www.html folder, which will just be an h1 element identifying the server as server1. I'll also create a file for the health check, and finally start the HTTPD service. For web server 2, this will also be a T2 micro, but the image ID will be obtained through a custom resource, which is a Lambda function. Its value will be obtained from the attribute of this AMI info resource ID property. So if we look at AMI info, this type is a custom AMI info type. Its properties has a service token, which we'll get from an attribute from the AMI info function's ARN. In the AMI info function is an AWS Lambda function type. The properties indicate that the code for the function will be in an S3 bucket named ccAMI lookup.js, and that the key will be AMI lookup.js.zip. Its handler will be the AMI lookup handler, and its runtime will be Node.js 16. The execution role will come from a Lambda execution role resources ARN, and that's defined here of type AWS IAM role. Now, the code for the AMI lookup.js file is a sample Lambda function that looks up the latest AMI ID for a given region and architecture. Now, I didn't write this code. It comes from the CloudFormation User Guide's Custom Resources section, and it's the walkthrough looking up Amazon machine images, IDs, content. I'll leave you to read through this documentation to obtain the code. You could download the code as a zip file, which is what we'll need to put in the S3 bucket. But for now, we'll jump back to the YAML file, copy the name of the S3 bucket, and then jump over to the S3 console. Here I'll create a bucket, give it the name, and then upload the zip file. Back in VS Code, we'll turn our attention back to the AMI info resource and move from the security token to the region property, which will be a reference to the current AWS region. The architecture for the AMI info will come from the AWS info type 2 arc mapping that I created above. It'll be a T2 micro and pull the appropriate architecture. Looking back at Web Server 2, its subnet ID will be imported from the VPC, Private App Subnet 2, and the security group will be imported from the VPC, Web Server Security Group. It'll use the same key pair as Web Server 1 and have a similar user data script, with the difference being the ID of Web Server 2. To create this stack, I'm going to use the CloudFormation console. I'll click Create Stack with New Resources, select Upload a Template, and then pick the EC2 template YAML file. Then I'll click Next, give the stack a name, click Next, Next, and then here I want to show you that this stack will require the capabilities for IAM role. So I'll click here to acknowledge that AWS CloudFormation will create these IAM resources. Then I'll create the stack. And with the web server stack created, if we jump over into Lambda, we'll see our Lambda function. And if we jump over into EC2, we'll see we have two running EC2 instances for Web Server 1 and Web Server 2. Now let's jump back over to VS Code and take a look at this ALB template YAML file. Here I've added a resource for an Elastic Load Balancer v2 load balancer type. I've given it a name property, and the security groups will be imported from the VPC's ALB security group. The subnet list will be populated from importing from the VPC the public subnet 1 and public subnet 2. The ALB target group will be an Elastic Load Balancer v2 target group, and I've set values for its properties. The targets will be a list which will have an ID which will be imported from the web server stack web server 1 and from the web server stack web server 2, and will be exposed on port 80. The target type will be instance, and the VPC ID will be imported from the VPC. There'll be an Elastic Load Balancer listener whose Load Balancer ARN property will be a reference to the ALB. It'll listen on port 80 over HTTP, and I've specified the default actions for the redirects. Finally, we'll bind a certificate to the ALB listener on port 443 over HTTPS, setting the Load Balancer ARN property as a reference to the ALB. The certificate's certificate ARN will come from a parameter stored in parameter store. So to create this, I'll jump back over to the AWS console, jump into Certificate Manager, and request a certificate. I'll enter a domain name and then request a certificate. Then open the certificate and copy the ARN. Now in parameter store, I'll create a parameter for the certificate. And then create the stack. Now with the ALB stack created, if I jump over to EC2 and go down to load balancers, we see our load balancers created. If I copy the DNS name and open up a new tab in the browser, we see our web server 1 is loaded. And if I refresh, we're redirected to web server 2. Now, back in VS Code, we'll look at the last template, which is a YAML file to create an auto-scaling group. The first resource type will be an EC2 launch template. I'll give it a name, and the image ID will be a reference to the EC2 AMI ID parameter in parameter store. The key name will also come from the key pair in parameter store, and the security groups will be imported from the VPC web server security group. I'll create an SNS topic to get notifications for the scaling, and I'll store that in an SNS email parameter in parameter store. And save the parameter. The ASG will be an auto-scaling group. I'll give it a name, and the VPC zone identifier list will be imported from the VPC for private app subnet 1 and private app subnet 2. And I've populated the rest of the ASG's properties. The scaling policy will be targeted on a change in capacity, and the auto-scaling group name will be a reference to the web server ASG created above. And finally, I've added alarms for the scaling policy. So the last thing to do is create the stack. And with the stack creation complete and our resources created, we could head over to the EC2 console and we see our auto-scaling group is working. So that concludes this demo of creating a VPC and associated resources using CloudFormation. I hope you found this useful.